Hello and welcome back to the bifurcation video series. This will be video number 2, and I'm Tim Mickley, an R&D engineer at Maple Grove, here to discuss some of the topics about stent performance, particularly radial strength, recoil, and how these pertain to good side branch stenting. To start with, if you would look at the animation in the lower left-hand corner of the screen, you will see a picture of a stent expanding and contracting. Essentially, when a stent expands and contracts, you are opening up the zigzag pattern or trying to collapse it. If you look at the picture in the lower right-hand corner, you see a close-up of a pair of struts. Again, when you expand a stent, you open up the zigzag. And if you really think about this, where you're actually expanding the stent and deforming it is in the plane of strut width, not in the plane of strut thickness. To further explain that, I have this simple piece of wire, but if you think about it, this would be strut thickness, this would be strut width. As I expand the stent, I'm actually bending it in the plane of strut width, not strut thickness. I am not bending the stent in the plane of thickness. Why is this important? If you look at a very simplified engineering equation in the upper left corner, you will see that radial strength in a very simplified manner is strut thickness times strut width to the third power. So a small change in strut width is much more impactful than a change in strut thickness. Also, if you look at the cartoons in the upper right, you will see that although Synergy is thinner than Premier, the strut width is actually slightly wider. And this is across the board on all of the Synergy and Premier diameters. You will always see a slightly wider strut with Synergy. So therefore, any little bit of strength we lose by reducing the strut thickness, we make up for by having a wider strut. Next, I'd like to talk to you about stent recoil. Just to make sure we're all grounded on this, anything made of metal, like this wire, right, when you bend it and then let go, it snaps back. That is called recoil. It happens again with anything made of metal. Why is that important in stent design? Well, if we look at the 3 images on the slide, you will see that Synergy has a peak that's wider than the struts, Zions has a peak that's narrower than the struts, and Onyx, being that it's a continuous wire design, has consistent geometry throughout the peak and the struts. So again, why this is important is when you think about a stent opening, again, we're trying to expand the zigzags, and on these slides, anything that's colored light blue or green is the area of the stent that's actually deforming during expansion. So you'll see with both Resolute Onyx and with Zions, we have bending throughout the entire peak when the stent is expanded. When we move to Synergy, you will see that because of our wider peaks, we focus the bending area to 2 small locations just adjacent to the peak. And plain and simply, less area being bent leads to less area that can recoil. So we'll have less recoil with the Synergy design than these 2. To give you an example of that, again with this wire, we'll just make a simple strut. And again, when I expand it with the balloon catheter, deflate the balloon, it snaps back, recoil, right? Because we're bending throughout the entire peak. Where with Synergy, if we focus our bending adjacent to the peak, we balloon it open, deflate the balloon, it does not recoil as much. So this is one of the advantages of the Synergy design. It has lower recoil than most other stent designs. So another common question we get on stents is, as you post-dilate a stent, for example, our 4.0 can go to 5.75, as you post-dilate that stent, does it become weaker, or is there higher amounts of recoil? Actually, it's kind of counterintuitive, but if you look at the slides, you will see that we actually have a small increase in radial strength and a pretty significant decrease in recoil as we overexpand stents. So why is this, you might ask? Again, if I go to this simple piece of wire, what is stronger, a column, a straight column, or a column with a bend in it? All right? Obviously, a straight column is stronger. So when you over-expand stents and post-dilate them, essentially you're bringing the struts closer and closer to that perfect column, so therefore you gain radial strength as you over-expand stents. On the bottom of this slide in the lower right-hand corner, you'll see two images. One is a Xience stent, one is a Synergy. This is looking at a shot of the stent through the side branch down onto the main branch. Why I bring this up is we've been talking a lot about strength and recoil over the last few slides, and this is extremely important when you get into bifurcation stenting. So just like stents can recoil and change in diameter, when you're ballooning open a side branch with a balloon during, like, for example, kissing balloon technique, you also get recoil of struts. So when you have a design that has high strength and has less recoil, you will usually end up with a much clearer, wide open patent side branch. Another important feature of stents is flexibility. There are several design elements that make Synergy and Premier more flexible and conformable than most stents. To start with, a two-connector design. And if you just simply think about it, when you have two connectors, it's very easy for the stent to bend. When you have three connectors, right, it makes it much more difficult for a stent to bend. And therefore, two connector designs will most likely always be more flexible than three connector designs. If you look at the images on the left, you will see that if you look carefully at the stent geometry on the Resolute Onyx, you will see the peaks of these stents actually are perfectly in alignment. If you look at the Synergy pattern right below that, you will see that one peak nests inside of the other peak. We call this nested peaks. All right, the difference here is if you look at the two drawings in the center of the slide, you will see that as you start putting a stent around a bend, with the Onyx, the peaks start to collide on the inside of the bend, and therefore it becomes stiffer as you start to bend it. Whereas with Synergy, the peaks nest, so you can get a much tighter curvature of radius on the inside of the stent. Plain and simple, like on Onyx, when you start to bend it and the struts collide, or the peaks collide on the inside of the edge, the only way that stent can conform and become more flexible is by creating gaps on the outside edge of the stent. This is also depicted pretty clearly in the picture on the right. You can see in a mock vessel, you can see where Synergy actually conforms very nicely to that radius, whereas Onyx is much straighter, creates a vessel hinge on the edge of each stent, which can lead to flow disruption, higher stresses on the ends of the stent, which could lead to dissections or even edge stent stenosis. Here's a great example of the importance of having a flexible stent design, especially when you start talking about long stents like 48 millimeters. In this video, you will see a Synergy 48 millimeter stent and a Xience 48 millimeter stent. And notice the edges of the stent and the vessel hinge that's created by the stiffer Xience stent. We've covered a lot of great content today that will help you further your credibility with your customers and drive our overall stent business. I'll close by reviewing a few key takeaways from today. Synergy BP stent struts are strong. Strut width is more important than strut thickness for strength. Synergy BP stent has less stent recoil due to focused strut bending. Radial strength and stent recoil are improved as stents are overexpanded. Strength and low recoil are needed to maintain vessel lumen and side branch opening. Two connector design improves flexibility, conformability, and reduces vessel straightening and vessel hinge points. Please make sure to bookmark this training video and refer back to it as often as you need. The next video will cover visibility, foreshortening, and side branch access and expansion. Thank you for watching this film today, and we will see you back for video 3.